Hello and welcome everybody to the next video tutorial for the ECAM tool. Last time we learned how to read and use both the energy and the greenhouse gas summary. Now I would like to present you a short task and I would like to go that task through together with you. Here's the task. It actually just refers to the fecal sludge management stage and it's not applicable to the water supply, the wastewater stage. So here's the assignment. Pure Ethiopia is the home of 30,000 people and lacks of a well-developed fecal sludge management plan. 45% of the people still defecate outside and don't have access to improved sanitation facilities. The other 55% collect their excreta in septic tanks. 80% of the tanks are being emptied, whereupon the sludge is treated afterwards with sludge drying beds, finally finding its use in agriculture. For the whole process, 5 gigawatt-hours of electricity is needed. Additionally, 2,500 liters of diesel are consumed by trucks for emptying and transportation. Task A is to calculate the current total greenhouse gas emissions after 1 year. For that, please use the estimations given by the tool. Task B, think about ways to reduce the greenhouse gas emissions. So let's do that task. And we can see also here just a summary of the facts given in the text. And here we can see a sheet flow diagram which actually shows the difference between on-site sanitation and open defecation by the population. So there's actually 45% of the population which is not connected to any kind of treatment or containment system and just basically open or use or have open defecating outside. But there are 55% of the population where the sludge being produced at the household level is going to be treated. So let's go to the page of ECAM. Click on New to create a new assessment. Let's choose a name, let's say Beer for the facility. And we actually know that the text says that we would like to have the current total greenhouse gas emissions after 1 year. So we can just leave the assignment period. Here, the assessment period shows that it's 365 days, which equals 1 year. Let's continue. And since the task says that the town lacks of a well-developed fecal sludge management plan, we are going to activate only the fecal sludge management stage in our system. So let's activate it, the containment, treatment, and reuse disposal also. Then we choose Ethiopia as our country and immediately get the values we need. We can continue. Then we will type in the number of the people living in the town. It's saying here that it's 30,000 people. Population with on-site treatment, let's have a look at the text. It says the other 55% collect their excreta in septic tanks. So 55% out of 30,000 are actually 16,500. Let's add this and continue. And let's start with Tier A, the initial greenhouse gas assessment. As you knew before, it's not the detailed greenhouse gas assessment, it's just an initial one. So it's not that detailed. But we'll have a look at the detailed one also later. So the first we should type in is the energy consumed from the grid in the FSM stages and vehicle sludge management stage. Let's have a look. It says here 5 gigawatt hours. Now we need to be careful because the unit is kilowatt hours. So we need to multiply it with 1000. We have 5000 kilowatt hours. The volume of the fuel which is consumed is 2500 liters of fuel. Containment is going to be emptied 3%. So at the household level, the people collect the sludge or the excreta with the help of a septic tank where it is stored, and afterwards it's going to be collected or contained by trucks and further dispatched to the treatment facilities. So it's 80%. We don't experience flooding or groundwater infiltration since it is not mentioned in the text. The main containment type is the septic version. The sludge is treated in the septic tank, and with the help of the sludge drying beds, it is treated. So we can put the sludge drying beds here. The main disposal type is, so we can just assume that the sludge is disposed after the treatment. So there's a treatment and it's used in agriculture. So treated. Actually, we are not producing biogas, and we are also not using or valorizing biogas. So now we actually set all the values we need, and since we should use, as it is stated in the text, please use the estimations given by the tool, everything is set already. We can have a look at the containment stage, closer look, where the greenhouse gas emissions are actually very high. As you can see, total greenhouse gas fecal sludge containment greenhouse gas emissions equal almost about 2 million. So we can have a closer look at the values here. The methane emission factor equals, according to the septic system, 0.3 kilogram methane per kilogram biofuel oxygen demand. The fecal sludge density is already set with the program, and also the BOD concentration is set. We have the fuel type, and we have the volume of the fuel which is consumed by the trucks for the containment. Then we can just continue to the treatment stage. Here actually it is striking that no greenhouse gas emissions arise from the treatment process. This refers to the methane emission factor, which equals 0, since the sludge drying beds have no emission factor. It is just 0. So this method doesn't require electrical energy, but its disadvantage may be that it is only applicable during dry seasons. Anyway, the treated sludge is disposed in the last step. Let's go to reuse and disposal, where we also have set the estimated values given by the program, as you can see. And also here we can see the total emissions, it's about 100,000. So all the values are set. Let's go and have a closer look at the greenhouse gas emissions summary to answer question A. As you remember, question A was to calculate the current total greenhouse gas emissions after 1 year. So as we can see here, the program already calculated those for us. It's about 2,300,000 kilograms of CO2 equivalents per year. So we answered actually task A. So we have just left task B. Think about ways to reduce the greenhouse gas emissions. The first look, of course, you can think about some opportunities, what we can do, for example, valorize biogas or sequestrate carbon. And as I showed you in the previous tutorials, we can just go to the opportunities page and see what values we can change to reduce our greenhouse gas emissions in our system. For example, we would be able to add biogas production to use the energy and electricity created through the process to save greenhouse gas emissions. In this case, actually it is not a percentage change, because it says here you must enter cubic meters of additional biogas production and recovery. So let's say we produce 500,000 cubic meters of biogas, and we can see there's a difference from about 2,300,000 kilograms CO2 equivalent. It is reduced to about 2,250,000 kilograms CO2 equivalents.